What are you gonna diameter of laughter?
What? Oh, I get it.
Oh.
These will continue. This is November 15th. And this is 4th.
So Rolle's theorem suppose you have a function f of x that is continuous on the closed interval a comma b, differentiable on the open interval a comma b, and f of a is equal to f of b, then there has to be a point, or there will be a point, c, that is in the open interval a comma b, such that f prime of c is equal to 0. B, why did I go from a closed interval to an open interval?
Because the closed interval at the very least is saying that it's including these numbers. The second one is the very least saying that it's excluding these numbers. So thus you have a range generally.
But why? Why did I go from this to that?
Can't have a derivative on a b.
We cannot have a derivative at an endpoint, right? So differentiable on an open interval a comma b. So there is a proof for this, but I'm not going to get into the proof, but I'll do it via illustration. Let's say f of a is equal to f of b. Some value here, let's call it y1. So the value of the function is the same as f of a and f of b. So what the theorem states is if I start at a, there has to be a point in the middle where the derivative would be equal to 0. Does that make sense? Now, what would it mean for a derivative to be equal to 0 at a point C? It's a critical value. So what does C imply if it happens to be a critical value? Then should be the other way around, but it's okay. I'll go with this. What does it tell us if the derivative, first derivative, is 0? There is a term, right? So if I start here, I cannot get back to that point without turning. Do you agree? So I have to turn somewhere. And there is that point. See? Yes. Let me take another curve. And let's say this one's in red. Starts this way, could I get to that point B, or that point, without turning? Not possible. So I have to turn somewhere to get to that point. So here, the first derivative is 0, call that point C. First derivative is 0, let's see one. And then there is a trivial case. The last case is trivial. I start here, I end there. Correct. And do you see a turn? No. So did that guy make stuff up?
What was the third? Oh, okay.
So when I started, oh, there has to be a turn. There has to be a turn. You all agreed. And now I just drew a line, a horizontal line, which is a function. Do you see a turn? No. So did that guy make stuff up? Yes. Yes.
No, the differential. B.
Oh, you're saying that that's not differentiable?
Or at least it wouldn't create. C.
No, it's just a line.
No, it's the slope is still 0.
Exactly. The slope is still 0 at every single point between A and B. Do you agree? So what the theorem simply states is that you will find a point C on the open interval A comma B, where the derivative would equal to 0, the first derivative. But it does not say that it must correspond to a local minimum or maximum. Oftentimes, when we do find a critical value, it ends up being local minimum or maximum. But the theorem doesn't say that. It rather says if I have a point A, point B, and if they are the same, the value of the function, then there has to be a point where the derivative is 0. Good. So
We said it in the last one.
not necessarily a maximum or minimum.
So not necessarily maximum, but a change in direction, right?
It's not needed either, right? A change in direction could only happen if you have a maximum or minimum, right? So all we are saying is you will be able to come up with a point where the derivative would equal 0. But the conditions are A, B, and C. It has to be continuous. It has to be differentiable, and f of A must equal f of B. Good. I saw a hand go up. I left this on the side because being effective formulation. So the function has to be continuous on A comma B, closed interval. So that is a closed interval, -1, 3. Do you believe that that function is continuous? So just by knowledge from algebra, that is a parabola. And what is another way to verify if it is continuous or not? Graph it using your calculator. If you graph it, there will be a curve on that interval that is continuous. Even before you start the problem, would that particular function have a minimum or a maximum? Minimum. Why?
It's not flipped. It's a parabola.
Stop it.
It's a parabola.
Oh, so every parabola will have a minimum?
Well, no, not always.
What's
No,
positive?
The degree.
What is this?
The degree.
It's a wave.
The leading coefficient is positive. I know what you guys were talking about, but all kinds of stuff. So it is positive. So knowledge from algebra, it has to open up, which implies there has to be a minimum. So pay attention to the verbiage concave up. So this is concave up. We will do this in 4.3. That said, if there is going to be a minimum, which we know in this case, f prime of c will be 0 at that point. So I just want to know if that c lies in that interval. For that to be true, it has to be differentiable. Yes. We want to verify if f of a is equal to f of b, third condition. The first two are true. The third condition, f of -1, two times -1 squared minus 4 times -1 plus 5. I get 11. The next point, f of 3. Nine times 2, 18. 18 minus 12 plus 5, I get 12. So condition 1 is satisfied, condition 2 is satisfied, f of a is equal to f of b, condition 3 is satisfied. So Rolle's theorem best be true. There has to be a c that lies between -1 and 3. To find that c, all I'm going to do is take the derivative. So f prime of x will be 4x minus 4. Standard process. And I'm going to set that equal to 0. For x minus 4 would equal 0. Are you okay?
For some reason, I'm just gonna sneeze.
So 4x is 4, divide by 4 on both sides, x is 1.
I think the mask is dusty.
So x is that critical value where the maximum is at, minimum is at. Does that point x belong to that interval? Yes. So the 1 lies between -1 and 3, so the theorem is true. Good.
There was an easier way to figure out.
So condition 1 is true. The function is continuous on pi over 2 and 3 pi over 2, including the endpoints. It is differentiable because sine is a differentiable function and it is on this interval. We just want to make sure that that holds true. So sine pi over 2 would be sine pi over 4, which is 1 over square root of 2, which is the same as root 2 over 2. Plug in the other endpoint, sine 3 pi over 2 sine 3 pi over 4, which is also 1 over square root of 2. You can use your calculator. So condition 1 is true, condition 2 is true, it's also true. We just want to see if we can find that c that lies between pi over 2 and 3 pi over 2. To do that, I'm going to take the derivative. Derivative, we have to use chain rules. Derivative of sine is cosine x over 2. And for some odd reason, guys had difficulties with this, finding the derivative of x over 2 using quotient rule.
You treat one half as constant.
1/2, you don't have to treat it, it is a constant. So x over 2 is simply 1/2 times x. But what is the derivative of that?
It would just be 1 times 1/2, meaning that'd be 1/2.
Yes.
Hey, at the very least, we didn't just stop right there because like, wait a second, how did we get to it? We used prior knowledge.
Now we set that equal to 0 and solve for x.
Which is pi.
So 1/2 cosine x over 2 must equal 0. Going to erase this part.
I recommend that you put cosine x over 2 correct.
So multiply by 2 on both sides, we have cosine x over 2 equals 0. Now, at this step, you can use the unit circle to determine the value of x. If you don't want to do that, this is a trigonometric equation. What will cancel out cosine? Cosine inverse will. So if you take cosine inverse on both sides, cosine inverse of that term on the left hand side, cosine inverse of 0 on the right hand side, squiggly, those two will get cancelled. X over 2 would be cosine inverse of 0. Your calculator has cosine inverse function, and that would end up being pi over 2.
Which you times 2.
So the 2's will get cancelled. So x is pi, and pi certainly lies between pi over 2 and 3 pi over 2.
Hey, so I have a couple questions. When it comes to making sure it's continuous, you just graph that and see exactly, if there's no breaks or anything like that.
Exactly.
And then with differentiable, that's just making sure you can find the derivative of it.
Exactly.
And then the third condition is just making sure they both equal one another. But when we have the critical value, is that just another piece of that we need to find?
The critical value, whatever you find here in Rolle's theorem is the critical value. Always. What question?
No, I was just about to say that, I was just about to say comments. I was
Okay.
like,
Yes, and
So if it doesn't lie in the interval, when the x at the beginning,
if, what do you mean if it doesn't? If you couldn't find a C?
yeah,
If you couldn't find a C, then it simply implies one of those conditions was violated. So if you can't find a C, then you're saying things are contradicting Rolle's theorem, and the only way that could happen is when one of these is violated. Good?
but, so your final answer would be which one is wrong?
In that case, yes. I'll do a problem.
So is this
So
one?
this is a problem where we have a function f of x is equal to tangent x. Tangent is a trigonometric function. First step, we want to verify if this is true. So f of 0 is simply tangent of 0, which is 0. F of pi is tangent pi. That is also 0. So condition C of Rolle's theorem is true. Is the function differentiable? Well, we know the derivative of tangent exists. What is the derivative of tangent? Secant squared x. So is it reasonable for me to say that the function is not differentiable?
No, but it is reasonable for you to say it's not continuous. continuous.
Yeah.
Okay, so, Alejandro's point is it is reasonable to say that it is not continuous and but it is okay to say that it is differentiable because the derivative of tangent x is secant squared x.
Yep, there is a
That's-
point along the tangent x line for each of the, let's just say, parts, right? Where at the very least, it does have a turn, or at least where the slope is going to be zero, like flat horizontal line. However,
Stop right there.
Yes.
Now, I think he sort of answered it, so. Why is this not continuous on 0 to pi?
Like, because there's a vertical aspect.
There is a vertical asymptote, infinite discontinuity, no jump, there is a break. So if it violates that condition, I'm going to say it is going to violate that condition also.
really? Because that really depends on the, that really depends, at least in my opinion, on the, what do you use? Domain, at the very least, on the range of domains, because you could have it within one of the things there.
Why do you say it could violate that?
Yeah, but I'm asking you.
What?
I just don't know.
So I agree to the comment that the function is continuous, not continuous on pi over 2.
Oh,
Yes, excuse me, at pi over 2. I agree to that, so it is not continuous on the interval 0, pi. But earlier in the conversation, Alejandro said, and a few others, that we will agree to this condition not being true, which is why Rolle's theorem is not going to work. They told you that there is no. But I'm making an argument that B is not true.
which
either.
is correct.
Isn't it because it has endpoints?
The endpoints are
The
0 and
discontinuities.
pi. So it's
Well, because you can't take the derivative at infinite discontinuity.
very good. You cannot take the derivative exactly at 0, at pi over 2. For one thing, if you graphed it, the tangent function is going to go like that, a weird S, and then it's going to go like, not S, and it's going to go that way. So at the asymptote, the limits will not exist, or the limit doesn't exist. So there is clearly a discontinuity. So the function is differentiable on 0 to pi over 2, union pi over 2 to pi, but it is not differentiable on 0 to pi. See the difference? What did I do? I just excluded the point pi over 2 because the function is not differentiable at pi over 2. Good? Does that make sense?
Lovely, honestly, for pointing out